There's something terrifying is headed our way. No sound, no warning, and no way to stop it. They thought it was just a satellite galaxy, just another cosmic neighbor floating quietly near the Milky Way. But astronomers peering into the Large Magellanic Cloud, the LMC, found something else entirely. A supermassive black hole, 600,000 times the mass of our sun. And it's not just floating, it's moving, not aimlessly, but with direction. Its destination, the Milky Way, and it's on a collision course. Now, before panic sets in, let's be clear. This isn't happening tomorrow. But the real story isn't just about when, it's about what this means. Not just for our galaxy, but for our understanding of the universe. Because this black hole, its size, its speed, its origin, challenges everything we thought we knew about how galaxies form, evolve, and collide. The first clues didn't come from a telescope staring directly into the LMC. They came from stars, stars that shouldn't have been there. Out on the Milky Way's edge, 9 stars were clocked moving at nearly 1,000 kilometers per second, fast enough to escape the gravitational grip of the galaxy itself. Astronomers traced their paths backward. Their origin, not the Milky Way, these were hypervelocity stars ejected from the Large Magellanic Cloud, and something big, very big, had thrown them. This is where the Hill's mechanism comes into play. Picture a binary star system, 2 stars orbiting each other. If they get too close to a black hole, the intense gravity can shred that dance apart, hurling one star out at incredible speeds, while the other spirals in, consumed by the beast. That beast? The hidden black hole at the center of the LMC. It wasn't guesswork. The European Space Agency's Gaia mission, with its precise mapping of over 1 billion stars, gave astronomers the data they needed to connect the dots. And the picture that emerged was terrifying. This isn't just another black hole. It's what scientists call an intermediate mass black hole, a cosmic rarity. Until now, we've mostly observed 2 kinds: stellar mass black holes, formed from collapsed stars, and supermassive black holes, sitting at the hearts of galaxies like Sagittarius A star in the Milky Way. Intermediate mass black holes have always been the missing link, the bridge between the small and the incomprehensibly massive. And here it was, hidden in a relatively small galaxy next door. The implications are profound. If a galaxy like the LMC, a mere satellite of the Milky Way, houses a black hole this large, then how many others are we missing? How many quiet neighbors are hiding giants at their core? This find reshapes our theories on galactic evolution. It suggests black holes can grow not just in large, bustling galaxies, but in modest ones too, and that the universe might be teeming with more black holes than we ever imagined. So, what happens now? In roughly 2.4 billion years, the Large Magellanic Cloud will spiral into the Milky Way. This is not a slow drift. It's a destined impact, a galactic merger, and at the heart of it, 2 black holes, the one in the LMC and our own Sagittarius A star, a supermassive black hole weighing in at 4.3 million solar masses. The LMC's black hole will be pulled inward, forming a binary system with Sagittarius A star. Eventually, these 2 giants will merge, releasing a burst of gravitational waves that will ripple across the fabric of spacetime. But the collision won't stop at black holes. The Milky Way itself will be transformed. Its spiral arms, those elegant curves we associate with galactic beauty, could be shredded. The chaos will trigger waves of star formation as gas clouds crash and compress. The result? A new galaxy, likely an elliptical one, and the Milky Way as we know it is gone. We tend to think of black holes as mysterious monsters, but in truth, they come in all sizes, each with its own story. At the center of our Milky Way lies Sagittarius, a star, weighing in at 4.3 million times the mass of the Sun. It quietly holds our galaxy together, influencing the orbits of stars like an invisible conductor. In 2022, scientists finally captured its image, an eerie, glowing ring confirming decades of theory. But Sagittarius A star is small compared to M87 star, a black hole in the Virgo cluster that shook the world in 2019. It was the first black hole ever imaged. That photo, it wasn't just a scientific breakthrough, it was a moment where humanity saw the unseeable. M87 star is a cosmic heavyweight, tipping the scales at 6.5 billion solar masses. And then there's TON 618, a name most people have never heard. Yet it's among the largest objects in the known universe. Over 40 billion solar masses, TON 618 is so powerful it fuels a quasar, a beacon visible from billions of light years away. Compared to these giants, the black hole in the LMC may seem modest, but its significance lies not in size, but in location and timing. It wasn't expected. A black hole that big in a satellite galaxy that small, it defies conventional models. It proves something crucial. These giants don't just sit in massive galaxies, they hide in smaller places, lurking, growing, preparing to collide, and when they do, they don't just change local star systems, they reshape entire galaxies. With each discovery, the universe reveals a little more, but often it raises more questions than answers. And when it comes to intermediate mass black holes, we're still standing in the dark. We know the small ones, those born from collapsing stars, and we've found the large ones, those that dominate galaxy cores. But the ones in between, they're elusive, hard to spot, harder to explain. Do they grow by merging smaller black holes over billions of years? Are they born big, formed in dense stellar nurseries in the early universe? Or do they slowly grow, feeding off surrounding matter, gorging over time through accretion? This black hole in the LMC is one of the strongest clues we've ever found. But it's still just a clue. New technology may change that. The Vera C. Rubin Observatory, set to go online soon, will scan the entire night sky every few days, tracking changes, capturing motion, and potentially uncovering black holes not by their light, but by their gravitational fingerprints. We're also awaiting next generation X ray telescopes, capable of picking up subtle emissions that escape from matter swirling near a black hole's edge. These could confirm if more intermediate mass black holes are out there, hiding in satellite galaxies, faint star clusters, or even rogue black holes drifting alone through intergalactic space. Each discovery matters, not just to astronomy, but to the story of the universe itself. Because black holes don't just sit in space, they sculpt it. They guide the movement of galaxies, ignite starbursts, and rewrite cosmic structure. And if we don't understand where they come from, then we don't really understand how we got here either. The Large Magellanic Cloud's journey toward us might sound massive, and it is, but in the grand timeline of the cosmos, it's just the beginning. Because after that comes something even bigger, something we've seen coming for a long time, the Andromeda Galaxy. It's the Milky Way's twin in size, and it's heading our way fast. Right now, Andromeda is roughly 2.5 million light years away, moving toward us at about 100 to 10 kilometers per second. Scientists estimate the two galaxies will collide in about 4.5 billion years. And when they do, the result will be unlike anything we've ever seen. Imagine not just two galaxies, but trillions of stars interacting, clouds of gas smashing together, stars flung into new orbits, or out of the galaxy entirely, black holes spiraling into each other, forming binaries, and then finally merging in bursts of gravitational energy that ripple across the universe. The Milky Way as we know it, Its spiraling arms, its quiet balance will be torn apart, reassembled, reborn. A new galaxy will take its place, likely more elliptical, less structured, but still teeming with stars, planets, and maybe life. This is the rhythm of the universe: creation through collision, order through chaos. The black hole in the LMC is our first preview, a warning that what seems distant and harmless can eventually become the very thing that transforms everything. It reminds us that galaxies are not static. They are dancers in a gravitational ballet, sometimes graceful, sometimes catastrophic. And we are just along for the ride. If you found this journey through the cosmos as thrilling and chilling as we did, make sure to hit that subscribe button. We break down the universe's biggest mysteries and bring them down to Earth. And remember, the cosmos doesn't just surround us, it includes us. So the story isn't just about galaxies and black holes, it's about you. Stay curious, stay grounded, and keep looking up.